Hello students, this is Ajit Dave from platform of Sinals. Students, today we'll be doing certain good problems. Those problems which most of the students feel so that they are slightly tricky, or maybe they are not able to recollect, or maybe able to connect it with respect to one chapter with respect to the second chapter. And these questions will be certainly based on your JEE mains, as well as from the NEET also. Of course, these questions, many students must have gone through it in these particular 2 years of time. But since you have your upcoming exams very soon, I want you all to work out with these particular basic questions, and one has to do very sincerely with this so that you'll be able to get maximum output of it. The scoring what you're getting it should be slightly graded much more better. It should be slightly more. And that is only possible when you crack certain good questions based on your JEE as well as from NEET. Today we'll be having a mixed concept related to both these particular questions, either from JEE I'll pick up as well as from NEET also I'll be trying to pick up. But at the same time, the student should be able to tackle with these questions very, very easily. So listen to me very carefully, students. Whatever I'm speaking also, listen carefully, observe properly. If possible, try to note down the important points also, students. This will really, really help you out for your exams. And at the end of it, I want you all to certainly go for subscription for it, as well as liking it also, and do pass on comments, students. So let's start off with physics for JEE we consider. To start off with, students, let us go for first a basic questions related to electrostats. Now, since I'm picking up this particular chapter, electrostat students, that is, let me speak about a certain questions related to it. The questions, if in case if I happen to consider is, the time when I speak about for this question is, suppose if I happen to speak about an uncharged spherical conductor, students, hope you are able to get the diagram very proper. What exactly, students, I've taken is, I've taken an uncharged spherical conductor, students, is that clear, which is along, we consider the z-axis we consider. So I've taken an infinitely long thin non-conducting wire. And what am I trying to do? I'm keeping this particular wire parallel to the z-axis, students, which carries a uniform line charge density lambda. Let me put forward this particular question, student, and then we'll try to work onto it. Okay, students. Now listen carefully, students. I've written the question for y'all. Now it's a question related to electrostatics, and many of the students must be knowing the basics of electrostatics in this case. But I'll just read out the question for y'all, and hope that you will be able to solve and try to crack it and try to think what exactly the solution of this is. If you happen to look at the question, what exactly the question I've given to you, students? I've given you, and that's an infinitely long, thin, non-conducting wire, students. Please, it's an infinitely. That means the wire is made to move on either side, plus infinity to minus infinity. Okay, and non-conducting wire, okay, is parallel to the z-axis. Now this is a z-axis we consider, and carries a uniform line charge density lambda, students. So uniform charge density, what exactly consider? Lambda, students. That means what exactly I'm trying to consider, that I've taken an infinitely long non-conducting wire, यानी पूरा एक लंबा सा वायर है और उसको पूरा electrically charge करके रखा हुआ, uniform line charge density, but it's infinitely long and it is parallel to which axis? Z axis. लेकिन ये जो वायर है, क्या किया मैंने सर, ये वायर को मैंने पियर्स करके रखा है. So please highlight important terms also while solving questions related to it. It pierces a thin non-conducting spherical shell. Please, it's a non-conducting spherical shell. Let us take this is the center of the shell I'll consider. Now if I happen to look over here, it pierces a thin non-conducting spherical shell of radius capital R. Means if I happen to consider this is a spherical shell, I'll take this capital R as a radius of this particular shell in such a way that arc PQ subtends an angle of 120 degrees at the center O. That means now if I happen to consider, I need to show the charged, infinitely long charged wire, students. Now have a look into it, students, please. It's an infinitely long charged wire. What about point PQ they're trying to go? Please, this particular point PQ we consider as an arc. Can I call PQ to be as a chord of the same circle we consider? Yes. Is this particular thin wire we consider uniform line charge density? It has a charge onto it, and what exactly the charge per unit length we consider? That is lambda. What is lambda we consider? Is simply called as linear charge density, students. What is linear charge density I'll consider will be? So simply I can consider is what? So it's Q by L. That is what exactly? It's charged per unit length we consider. So now when I speak about it, so I have taken an infinitely long charged uniform wire. The word uniform stands for, that is the mass is uniformly distributed and the charge is also uniformly distributed throughout its length, students. ये जो वायर है वो पियर्स करके रखा हुआ है कहाँ पे? एक स्फेरिकल शेल के अंदर. रेडियस क्या है? कैपिटल आर है. अभी जो पॉइंट्स पी क्यू है वो क्या करते हैं? सर दे सबटेंड एन आर्क. Please wait, students. This particular subtends an arc of how much? It subtends an arc of 120 degrees. Where? At the center of the circle we consider. Now when you carefully look into it, students, what exactly this is? So this is radius of the circle. Agreed? What is this angle I'll consider? So this is 120 degrees, students. Now if I want to find out what exactly it is, which of the following statement is true or are true? That means it can be one or more than one option correct, students. Let us solve this particular question. So to start off with, what exactly I'll consider? So you have given me theta as 120 degrees, we have got it. PQ is an arc of the circle. Can you get a relation? The answer is no, students. Can you get a relation of this particular angle with respect to the length of arc and the chord? So what do? So if I happen to drop a perpendicular over here, means can I say I'm trying to consider a simple right angle triangle, and the basics all of you all are aware about it. A perpendicular drawn from the center of the circle to the chord bisects the chord, students. तो ये कितना होगा? सर ये 60 degrees होगा. Agreed. Now first of all let us go for triangle. Let us go for triangle. I'll put the triangle over here. What exactly triangle consider? So let us go for triangle PMO, students. What about angle POQ? is sir entire 120 degrees. So ये कितना होगा? सर ये 60 degree होगा. What is this PO we consider? So it's a radius of the circle. That is radius of the spherical shell, students. Of radius capital R we consider, which is non-conducting, and a uniformly charged infinitely long wire is pierced through it, students. तुम्हें पूछा गया है option A, option B, option C, option D. Which one out of it is or are true we consider? That means I can have either one or more than one option. So let us go for, first of all, your linear charge density. Lambda is equal to what? Q by L we consider. Now when I speak about it, what exactly the length I'll consider will be? So the length will be what? Length यहाँ पे क्या होगा? So length infinitely, the answer सुना students, infinitely long charged wire के बारे में बात कर रहा हूँ. तो length क्या पकड़ोगे आप? Length क्या पकड़ोगे? हाँ सर length तो chord होगा PQ. So can I say this length is nothing but I can consider simply PQ? Yes, I can take that. Now if I happen to consider my relation for sine of 60 degrees for this right angle triangle, what exactly sine of 60 degrees we consider is? So sine of 60 degrees is equal to what? So it's opposite side upon hypotenuse. Means can I say it's PM upon PO, students. What is sine of 60 we consider is? So it's root 3 by 2. What is PM? What is PM? So PM is half of PQ. These students, the answer is now. What is PM? What is PM, students? So PM is equal to half of PQ. Reason क्या है? A perpendicular drawn from the center of the circle to the chord bisects the chord, students. So now instead of PM, students, instead of PM, can I write down this in terms of what exactly write on PQ by 2? तो यहाँ पे क्या लिखूँ मैं? So this is PQ upon twice into PO. What does PO stands for? Radius of the circle. Hope this part is clear with the students. So when you go for this particular question, try to understand what exactly the question is speaking about. They have taken a certain spherical shell which is non-conducting. ओके उसमें से क्या किया उन्होंने, एक वायर को पियर्स किया जो इनफाइनाइटली लॉन्ग है और वो इलेक्ट्रिकली चार्ज है, यूनिफॉर्मली चार्ज. व्हाट एक्जैक्टली लीनियर चार्ज डेंसिटी फॉर दिस, सो इट्स Q by L. लेंथ क्या लोगे, सो जो वायर is two ends के ऊपर, that is what it's intersecting this particular spherical shell at point P and Q, I'll consider that becomes my length. So the length is PQ, students. Now when you move further ahead, what am I getting the value of PQ? So 2 and 2 will get cancelled. Therefore what exactly PQ? PQ क्या होगा? So this is root 3 by into capital R we consider. Of course, that's what we consider. Now when a student is looking into it, the answer is in the students, root 3 into capital R. Options क्या दिया है? Options क्या दिया है? Which of the following statement is or are true? Now have a look at the options. The electric flux through the shell, root 3 capital R lambda by epsilon 0. What is epsilon 0, students? We consider its permittivity of free space. As if we consider mu 0, its permeability of free space, students. And there's a strong interlink between students, electric field and magnetic field. शायद तुम लोग ने किया होगा. अरे हाँ सर, C small c is equal to 1 upon under root mu 0 into epsilon 0. mu 0 क्या था? Permeability of free space. epsilon 0 क्या है? Permittivity of free space. अरे हाँ यार, mu 0 और epsilon 0 अगर मैं डाल देता हूँ उसकी values, and if I happen to solve it, I'll get the answer as 3 into 10 to the power of 8 meter per second. अरे ये तो speed of light in vacuum हो गया. Yes, that means there is a strong interlink between electric field and magnetic field. यहाँ पे हमें क्या चाहिए? See the first option they've given you, electric flux of the shell. That's the first option. Second option क्या है? The Z component of the electric field is 0 at all the points on the surface, students. Option C क्या दिया है? Option C, what exactly, students, is given to you? The electric flux of the shell is how much they're given to you? Root 2 capital R L capital R lambda upon epsilon 0. I'll put forward this again. It's root 2 capital R lambda upon epsilon 0. Okay, that's the one. And the electric field is normal, students. What exactly is given to you? Normal to the surface of the shell at all points. Now when all these particular 4 options are given to you, and students, you have landed up to this, most of the students who are listening to me carefully or who are watching this particular video instantly says the answer is what? So option A. How do you consider? So root 3 is coming into it, capital R is also coming into it. और पूछा क्या तुम्हें? Electric flux. What exactly are telling you to find out? Electric flux. How do you put in terms of electric flux? How do you find out electric flux? We consider the total electric flux enclosed by the surface we consider is what? It's 1 upon epsilon times we consider. That means what exactly consider? It's lambda is equal to what? Q by L we consider. Are you getting it? So now if I happen to consider with respect to your electric flux, then electric flux will be equal to what? So root 3 capital R lambda upon epsilon 0 we consider. So that's one part. Second part we consider is what? The Z component of electric field is 0. Now if you happen to look into it, students, see the Z component. How are the charges? So the charges are uniformly distributed, students. Please, throughout the charges are uniformly distributed. अगर suppose मैं बात करता हूँ electric field का, अगर suppose ये तुम्हारा charge conductor है और ये positive charge है, तो can I say these are the lines of forces? These are the electric lines of forces. How the electric lines of forces are originated? Normally, students. They are all originated normally. ये कौन सा axis था? सर ये Z axis था. ये जो sphere का जो line center से pass हो रहा है, that is also passing through what? So it's Z, because these two are what? Parallel to each other. Now carefully look at the option B. The Z component of the electric field. The Z component of the electric field is 0 at all points. Now check out over here. Is this electric field intensity for uniformly charged linear density wire we consider is it along the Z component or it's perpendicular to it? It's perpendicular we consider. So do we have any Z component of electric field? No. The Z component of electric field is simply we consider as 0. So now if I happen to consider the total electric flux we consider is, okay, the total charge, please pay attention, the total charge enclosed into the surface, what exactly we consider will be, please, since we consider is root 3 into R into lambda, because what exactly lambda is equal to Q by L we consider. Is that clear? What exactly consider? Root 3 into R we consider, because that's the length of PQ. So I'll substitute this. Electric flux. What is total electric flux, students? What is total electric flux? Total electric flux, students, है क्या? Please, it's 1 upon epsilon 0, the total charge enclosed in that particular surface we consider. ये क्या है सर? ये एक रीस्टेटमेंट है फॉर गॉसेस थ्योरम. One of these statement is the total normal electric induction over a closed surface is the algebraic sum of the net charge enclosed by that particular surface. यानी summation of Q आ जाता है वहाँ पे. दूसरा क्या है? The total electric flux is equal to, students, 1 upon epsilon times the net charge enclosed. So now अगर किसी को total electric flux चाहिए तो ये तुम्हारा फॉर्मूला आ गया. ये कहाँ से मैंने लिया है? सर ये तो गॉसेस थ्योरम का है और ये हम यहाँ पे यूज़ करेंगे. What is the total charge? सर टोटल चार्ज कितना होगा? सर Q इज इक्वल टू √3 टाइम्स R इंटू लैम्बडा. ये कहाँ से आया? सर Q इज इक्वल टू लैम्बडा इंटू L. L क्या था? PQ है. PQ what you've got it? √3 इंटू R. Now can I substitute back over here? So now what's the answer? 1 upon epsilon 0, students. What exactly it is? Total charge. What exactly total charge I consider will be √3 into capital R into what exactly? Lambda. Have a look at this and have a look at option A. So this is simple and a basic question which most of the students can easily crack it, but somewhere you need to think. Now the points over here you need to keep in mind is that it's a uniformly charged wire we consider. That means the charge is uniformly distributed. It's an infinitely long conductor we consider. The electric field lines are always perpendicular. So now if I happen to consider this particular charged infinitely long wire and the axis of the spherical shell, how are these two are? So both of them are parallel to each other. So electric field कौन से direction में होगा? Sir perpendicular to the surface. I can look at the lines of forces. These are all the electric lines of forces. All these electric lines of forces. All these electric lines of forces we consider. So now, do you find electric field lines of forces along the z component? No, it's not along the z axis. That is why we went for option B. The z component of electric field is 0 at all points on the surface, students. So this is a simple concept related to your electrostats. Let us go on to the next question. Hope you are able to get this particular question properly, students. Let's go for the next question. Okay, students. The first question was based on the electrostats and it was based on two concept related to your electric flux. Okay, and it was your concept related to electric field intensity, students. Now we go for a simple question related to your current electricity. Let's see how many of y'all can think onto it and try to get the answer exactly equivalent to me we consider. Let me put forward the question to you all, students. This is a small circuit diagram, students. I'm giving it to you. If you look over here, this is point A. We have a resistor and another point B I'll consider having a resistor. Now this particular resistor is of 2 ohms. This resistor I'll consider with 4 ohms we consider. Now these particular 2 resistors are connected at point C by another resistance which is of 2 ohms, a switch. Now look at the other end of the switch, students. The other end of the switch I have grounded. Students. That means it's at 0 potential we consider. That's my switch we consider. Now over here when you listen into it, it said that point A is at high potential we consider and its potential at point A is 20 volts, students. And the potential at point B, students, it's 10 volts. This is 20 volts, students, and this is 10 volts, students, we consider. Okay, so once again I'll speak about it. You have point A at 20 volt, point B at 10 volt potential we consider. If you look over here, this point of the switch we consider is connected to the ground, we take it. The question asked us, find out the current. Listen carefully, students. Find out the current flowing. Find out the current flowing through this particular 2 ohm resistor we consider. Given to you that the current flowing through the resistor 2 ohm is I1, current flowing through resistor 4 ohm is I2, students. I need to find out the current flowing through this, but when the switch is closed. तो पहला switch open था. Again, जैसे मैंने switch close किया, let us say that the current flowing over here is I1, the current flowing over here is I2. I want to find out the current flowing through this particular 2 ohm resistor. Let us understand this particular question, students. Now to understand this particular question, students, first of all, switch is closed. Yes. The answer is no, students. ये क्या है? Zero potential है. That means C will be at a certain potential. मेरे को चाहिए क्या? सर मेरे को करंट चाहिए. कैसे मिलेगा करंट? कैसे मिलेगा करंट? अरे रेजिस्टेंस हमारे हाथ में है. किसी भी हालत में अगर इन दोनों के बीच में मुझे पोटेंशियल डिफरेंस मिल गया, of course I can find out the current, because students, all of you all know it. Current always flows because of difference in potential. Current never flows because of a potential. It needs a potential difference for it to propagate or to travel, we consider. Let us say that the current in the first case they've given to us I1 through 2 ohm, I2 to what? That is through 4 ohm, we consider. Now what happens when these two currents reaches at point C? What happens in that case? अरे यार ये तो junction law हुआ. Which law we consider? So it's a Kirchhoff's law we consider. Which law we consider? So it's a current law. Of course, we have Kirchhoff's first law we consider as current law. Kirchhoff's second law we consider as what? That is the voltage law, the mesh law we consider. Now if I ask you current law, that is Kirchhoff's first law is current law, does it obey law of conservation of electric charge? Law of conservation of electric charge, students. अरे हाँ यार, charges do not accumulate at the junction. As many charges approaching the junction, exactly that many charges per unit time will certainly leave the junction, students. So there is no accumulation of charges at point C. That means if I happen to consider the current from here will move, and the current from here will move, and the net current over here will be I. So what exactly my Kirchhoff's law? I is equal to what? So it's I1 plus I2. Does it obey law of conservation? Law of conservation of electric charge? Yes, it will certainly obey law of conservation of electric charge, students. I need to find out this capital I, students. What is the potential? Suppose अगर यहाँ पे मैंने point A दिया, B दिया है, C दिया है. Let us take this particular point D. Point D को क्या लूँगा? सर ये grounded है. That means the other end is buried into the earth. It's at what potential? So it's at 0 potential we consider. Now if I want to speak about the current flowing through it, yes, I'm going to use this mathematical relation. What exactly simple mathematical relation? Once when you get this, many of the students who are listening right now instantly will be able to crack it. अरे यार ये तो easy हो गया. Current दिया है, current पूछा गया है. I का formula क्या है? See यहाँ पे तो simple. I'll use Ohm's law. What exactly consider is? So delta V is equal to what? Delta V we consider upon delta V is equal to what? Delta I into R. So can I say delta V by R will be equal to delta I we consider? That means difference in potential will be equal to the current flowing through it. Yes, simply I'll be using Ohm's law. So now once when I use Ohm's law, what exactly I'll consider? Sir, यहाँ पे the total current flowing over will be what? Sir, difference in the potential. ध्यान से देखना students. यानी ये क्या होगा? So VC minus VD होगा. Agreed. ये होगा difference in potential. Agreed. Upon what? The resistance. What is the resistance over here? Is 2 ohms. Formula क्या लिया था? Please, the formula was we are Indians. V is equal to R into I. Okay, so I'm considered with what? That is V by R is equal to I. I'm using this relation. यहाँ पे क्या होगा? सर I1 के लिए क्या होगा? सर अगर ये I1 ले तो ध्यान से देखना students. Point A I'll consider to be at high potential. I'll consider point C in comparison to be at low potential. Difference in potential, that is VA minus VC upon the resistance we consider, will be the current flowing I1 through it. And the current is how much? 2 ohms I've given to you. Likewise, if you go for the third one, what is I2 I'll consider? Sir, यहाँ पे भी क्या होगा? Sir, ये high potential पे है. In comparison to this, ये क्या होगा? Low potential पे. But if I compare C with respect to D, C is at high potential and D will be at low potential. This is very important for a student to understand, because the flow of current is always due to the difference in potential, student. That's why I said VB is greater than VC. यहाँ से करंट जा रहा है, नहीं VA is greater than VC, students. Now when I look into it, plus what exactly? I2 को कैसे लिखोगे? So it's VB minus VC upon what exactly consider? So that's 4 ohms we consider. Now if I happen to solve it, what exactly? Cancellation will be there. 2 is a common factor in all the cases. So what exactly get it? So it's VC minus VB is equal to VA minus VC plus VB minus VC by 2. Look at the potential at point B. So potential at point B is 0. So what do I consider? So इसको मैं 0 ले लेता हूँ. VC मुझे चाहिए, ये होगा 0. How much is VA? So VA is 20 minus VC I don't know, plus how much is VB? 10 minus VC by 2. This is by 1. This is by 1. Now can I solve further and get the answer? Now see, it becomes much more easier. So what do I consider? If I happen to take it, what exactly? So this is 2 VC is equal to 40 minus 2 VC plus 10 minus VC. 2 into 4 will be how much? That is 4. 4 plus 1 will be how much? 5 VC will be equal to how much? 50. Therefore, what exactly the potential at point C kitna hoga? 50 by 5, that means how much? So 10 volt. पूछा क्या है तुम्हें? पूछा है करंट, तुम्हें इसका वोल्टेज मिला, कितना मिला? 10 वोल्ट. अगर सपोज यहाँ पे अगर ये 10 वोल्ट है, ये 0 वोल्ट है, तो इन दोनों के बीच में पोटेंशियल डिफरेंस कितना हुआ? 10 वोल्ट हुआ. V, हाँ सर V हमारे हाथ में. R, सर R हमारे हाथ में. पूछा क्या है? I, तो कहना है इसे 10 is equal to 2 into I. What's your answer? 5 ampere. So what's the total current flowing? Please, the total current will be equal to how much? 5 ampere, students. Hope this part is clear with the students. So please, when such kind of questions are getting it, to solve it, yes, you need to use your Kirchhoff's laws. Because see, Ohm's law can be used for simple circuits, but when you go for complicated circuits, yes, you need to go for Kirchhoff's law in that case. Whereas over here, I'm using your current law we consider, and that is law of conservation of electric charge. In the first case, VA is greater than VC. Over here, VB is greater than VC. But when I compare with C and D, VC is greater than VD. And the difference in potential causes the current to flow when the switch is closed. So what's the answer for this? 5 amperes. Of course, I didn't speak out the options. The options that given us 5 amperes, 12.5 amperes, 10 amperes, and 17.5 amperes, students. So the answer is how much? We get it as 5 amperes, students. Hope you must have understood. Of course, it was a short video we consider, and this particular short video, hopefully I feel like that will be helping it out in that case. But further ahead, students, if in case you feel that yes, things are really good enough, you're able to catch me very properly, you're able to understand properly, yes, we'll be going with respect to good topics related to your KTG, thermodynamics we consider, ray optics we consider, because these are the topics which have maximum weightage in your examination, students. So most probably we are trying to work out with short videos of the entire physics syllabus of your class 11th and 12th for your JEE mains and NEET separately. Of course, the JEE and the NEET will be certainly separately. In that case, we'll be working out with it. Hopefully that is, I feel that maximum students will start to subscribe it, enjoy it, like it in that case. At the same time, I want you to pass on comments with respect to it. Wish you all the best. God bless you all. Take care. Okay. See you soon.